Alright, so functions. Until now, you actually been already exposed to some functions. We didn't call it function. We called it a relationship. Okay, a relationship between, for example, there's a relationship between x and y, and we said that this was the independent variable, right? Independent. And this is a dependent, right? Dependent. Does that look familiar to you guys? So if you have an equation y is equal to 2x plus 1, we call this one the independent, this one the dependent. So we call this one the independent because this is sort of our input. Okay, so you pick a number. You pick 1, you pick 2, you pick 3. Okay, and then you do some stuff to x, and you assign the result to y. So we call this the output. Does that make sense, that analogy? You pick a number, and then 2x plus 1, the whole expression on the right side is telling you double the x, and then add 1, you assign that to y. Okay? So this is actually an example. It's an example of a function. Example of function. So as long as you do something to input, right? So basically we do some operations on x to get y. Okay, we call that y is a function of x. Okay, it sounds very similar to y has a relation. This is the word you use in grade 9. Relation with x. There's one actually very, very important condition though. Look, do you see here it says do some operations on x to get y, right? Very important. Okay, very, very important. Okay, we must get only one output of y for each input.
What does that say? Y has a...
Okay. Okay, so look, this is a definition of function. You have an x, which we treat as an input. You do whatever you want to it. But whatever it is that you do to it, right? I'm saying when we do some stuff to it, we mean like a mathematical operation. We do stuff to it, but we're whatever it is that we do, we must get only one output. If that's the case, we say that's a function. Okay. So when do we ever? How can we not get one? It seems like this one right here is pretty obvious. For whatever number you plug in, you get one output, right? Let's do another one. In parabolas, in quadratic, for every input, how many outputs are we gonna get? If you plug in 1 squared plus 1, y is 2, right? It's one output, right? If you plug in any number, like 3, 4, negative 5, whatever number you plug in, how many different y's are we going to get for that each input? Right? If you plug in negative 5, you get y is equal to 25 plus 1. You get 26, right? So you get 1. Okay, so can you think of a way to not get 1, get more than 1? Write an equation which will have actually, so you can write x and y, right? Write an equation which will have more than 1 for every single value of x.
Is it if it can be like positive or negative?
Okay. That's very, very close. You can have positive or negative. We did such an example. What is this, guys? You guys know what that looks like? That's a circle.
Oh.
Okay, actually, let me pick like 4. What happens if I pick x equals 1? You get y is equal to plus or minus square root of 3. There's two outputs here, right? This is not a function. So this relationship, there is a relationship still. There is a relationship between x and y, but not a functional relationship.
So that's not something that has more than.
Okay, so any equation between x and y, right, is a relationship between x and y. So look, if this right here represents relations, so any equation between x and y is a relation, but only some of them are functions. Okay, it must have only one output. This is what I'm saying. Okay. Okay, so let's just recap. What is a function? It's a relationship between x and y where for each input there's only one output. That's the definition. Okay. We do some operation to x to get y, but we must get only one output of y for each input. I guess I should say input of x. Okay, so to distinguish function and relation symbolically, we're going to introduce a new symbol.